Hello everyone, I'm Mohit and I will be presenting our project on web search engine in the subject Advanced Computing Concepts of Masters of Applied Computing at University of Windsor. First of all, I would like to thank our instructor Dr. Mohit for giving us this opportunity and guiding us throughout this course. My team members for this project are Piyush Garg, Sahil Darji and Jagan Kotapalli. Next, we have our table of contents. I will be going over the introduction now. So, what exactly is a web search engine? A web search engine is a software or a tool used to find information based on the keywords. Search engines parse several thousand URLs to provide relevant search results to the users. Passing through URLs includes scanning of the website name, its metadata, content inside the website, etc. etc. As you can see here, we have various different types of search engines, the most popular ones being Google, Bing, Yahoo, DuckDuckGo, etc. There are various types of search engines with a variety of features. For our project, we have included a web crawler, a URL indexer, a page ranking algorithm, and an HTML to text converter. We have used few concepts which we were taught in the lecture by Dr. Mahdi, and the concept we have implemented in the search engines are hash maps, sorting, particularly merge sort, then ternary search tree, and HTML to text using JSON. Next, I would like to pass on the mic to my colleague Piyush Garg, who will be explaining you more about the web crawler. Thank you.
Web crawler. Web crawler, commonly known as Spider or Spider bot, is an internet bot that systematically browses the World Wide Web, typically operated by search engines for the purpose of web indexing. It begins with a record of URLs to visit called the seeds. As the crawler visits these links, it identifies and locates all the hyperlinks in the pages and add them together with the list of URLs. URLs from the frontier are recursively visited according to the set of policies. Indexing is the position of an item inside an array, a list, or other data structure that has ordering. Ordering means that there is a concept of items, also known as elements, coming one after the other. For example, an array list with a size of 5 means that the array list has 5 items and the indexes of the items are 0, 1, 2, and 3, 4. Trying to access an index of 5 means you're trying to access a sixth item which doesn't exist and is bigger than the array list size. As a general example on how to use the hash maps for indexing, you can pass the integer and the string values in the hash map and store them in the URL indexes. Once the list of entities are prepared, hash map is used to index and arrange the entries by passing the integer and the string values. You Hash map has different methods as well, and you can use the .get method and pass the key value to get the particular value of the strings. To store all the URLs according to the search done, for that we used web crawler Python library Beautiful Soup. These were done after the first search was made. The library search for the keywords and lists down all the URLs found on the websites in the txt file called websites.txt. The URL stored were not indexed and stored in an unordered list. Therefore, we use the concept of hash maps for indexing of the stored URLs. The complete websites.txt file was passed inside the hash map and each URL was read line by line until empty. This way the indexing was done and they were stored in an array named URL index.
Okay, so now we have the feature HTML to text conversion. Since HTML files from URLs can't be passed directly, we used a Java library called JSON. Basically, JSON is used to manipulate the data fetched from passing the HTML files. Now let us see its code implementation to understand a bit more about how JSON works. To use JSON, we first have to download its jar file and integrate it to our project. So after integrating it, we will import the JSON library. To convert the HTML to text, we first fetch the URLs from the local file websites.txt, which consists of a large set of URLs. Next, we establish a connection to URL using the JSON's connect method and fetch the HTML files. After that, we convert those HTML files to plain text using the text method of JSON and then store them in a folder which will then be accessed during the search operation. Okay, so here we have an example on how HTML to text conversion takes place using JSON. So we can see that there is an HTML file. Here, as you can see, there is information on the title of the website, the content in the body, etc. What JSON basically does is parses over this content. It removes the HTML tags and just provides us the information that is necessary to us. This can be saved to a location of our choice or just be printed out.
Hi. Ranking is the feature which provides the content that best answers a searcher's query, which means that results are ordered from most relevant to least relevant. Depending on the query, there may be many pages of results. Therefore, the ranking refers to the specific page on which a given web page appears, as well as its position on that page. So basically, the ranking algorithms takes the user's queries, they fetch data, store them in the index, and in the stored data in index sends the data back to ranking algorithms, and the user then gets its result. Furthermore, we can say that when someone performs a search engines source their index for highly relevant content and then orders that content in the hopes of solving the searcher's query. This ordering of search results by relevance is known as ranking. In general, you can assume that the higher a website is ranked, the more relevant the search engine believes that site is to the query. We can understand this by an example. In the given image, website B has higher ranking than website C due to the higher frequency of word search. Similarly, we can see that website C has higher ranking than E, although it has less keywords but a more frequency of word search. Also, on the other side, websites A, D, and F have lower frequency of word search. Now, in the implementation part, utilizing the classroom teaching of text processing concept, we have implemented a ternary search tree using the tst integer function. Further, in the line 93, we can see that we have used the string tokenizer, which creates tokens and try trees. Also, in the line 127, we have used the hash map function, which uses the get frequency list to get the keywords, and it passes the keywords with the use of this function. Furthermore, we can see in the line 134 that using the file folder, we are getting the list of all URLs which are provided in the text file format. And in the line 158, we are initiating the object of ternary tree tst integer which we had created earlier. And also in the line 190, we can see that we are using the hash map function, which sorts the frequency list accordingly and gives us the result.
Okay, so now I will be explaining how our project works. First, let's walk through our project files. So here we have our project source folder, which consists of our main code, the required files for its execution. Then we have the JRE system library, which contains all the Java libraries which we'll be using in the project. Then we have a reference libraries folder, which contains all the dependencies for the project, such as the JSON. Then we have the sorting and the text processing folders, which have been taken as reference from our lectures taught to us by Dr. Mahdi Firuzjai. So in the source folder, we have the search engine files, the URLs, the hash map data, etc. Before understanding the flow of the project, let's see the output once. I'm sure that after seeing the output, understanding the flow of the project will be much more easier. So first, We will go to the URL to txt file, which will convert all our URLs stored in the local database to the text files, which will then be used for the search. As you can see, there are multiple URLs being shown in the console. These URLs are being scanned and converted to the text files, which are being stored in the ACC web search engine .urls. So next, we will look at the actual output of a search engine by searching a result. So let's search for nursing. As you can see, we have the top 10 results for nursing. Like these are based on the keywords identified. Okay. Okay. So now we will start by understanding the flow of the project. So we will begin understanding the flow by first going to the first section, that is the web crawler. Okay. So here we have the web crawler, which is in a Python file which we have run in the terminal to generate all the URLs of the domain uventure.ca, which have been stored in the websites folder, which is over here, or txt. For the web crawler, we have used the beautiful soup, which imports the all the HTML files from a certain domain, and we have then stored them to the websites.txt. Next, we have the URL to txt file. So the URL to txt file basically does what URL to txt file basically does is it reads all the URLs from the websites.txt, lists down those URLs, then converts each URL to a text file and stores them to the ACC web search engine.urls. Another thing, we also have a stopwords.txt file which consists of most of the keywords which are being used over here. So basically what it does is it is used as a comparison tool to compare the keywords which are present in the search, and then creates a keywords based on them to perform the search. Now to see how this works, let's go to our main Java file, which is the search engine.java. So let's start from the beginning. Okay, so first we have imported the necessary files over here, which are the java.io, java.util. Then we have referenced the text processing files, then the sorting files, and a collectors file. So what basically we have done is first we have fetched the keywords. These keywords fetching a system is what it does is when a user inputs the search, so the search is being translated, or I guess compared to the keywords in the stopwords.file, and based on the comparisons, it lists down all the keywords as tokens and returns those keywords. Then the second method is the index URLs. Index URLs basically indexes all the URLs which are present in the websites.txt. This is the indexing feature of our project. The next, we have used the ternary search tree to generate a tree of based on the text present in the URL files. So what this does is creates the tokens of all the text present in the URL file and generates a tree based on them. This tree will then compare all the keywords which are matching in the text file and create a frequency list of those keywords. So next we have that frequency list method. In this, all the keywords are matched with the in the tree. Like okay, we can see over here the tree is being generated. Then we are getting the final path, and basically what it does is it matches all the keywords which were generated in the get keywords method and compares them with the text with the tree generated. So to get a frequency list, what is the frequency list? So basically a frequency list is the count of the keywords which are present. So basically what this will help us do is it will help us get the rankings on the website. Like the number of keywords present in the website will give us the rankings. Like if the website has 10 keywords and another website has 5 keywords, then the website having the count of 10 will be ranked first. Next we have the sort. This the what it does is sorts the URLs which have been found by the keywords. So the URLs which have been identified having the keywords and have been listed in the list are then sorted in the order of the number of keywords present in each of them. Next, what we do is store all of the results, the frequency list, the keywords and everything, the URLs, everything is stored to an output file. Okay, so this will help us then retrieve all of those files to get the ranking. So here we have the retrieve hash map function. So basically, we have used the hash map function for all of our storing and retrieving operations. So the over here we get the URLs and rankings based on the sorted URLs, and this is what we output to the users. So the what the end user will see is this, that is the top 10 search results of a particular search. Okay, so that's it for the flow of the project, and I hope you enjoyed it. Now next part will be carried on by my colleague, and thank you.
Team has three members. Me, Piyush Garg, I did the web crawler and the indexing part. There's Mohit, who did the HTML to text and the documentation part. And there is Sahil, who did the ranking and documentation part. These are the references in the IEEE format. You can check those out. This is all from us. I hope you like the presentation. Thank you.